CU Boulder's Sweaty Buffs presents the development of a non-invasive cortisol sensor. A non-invasive what? Well, before we get into that, let's talk about astronauts. Astronauts explore the unknown. As you might expect, it can get pretty stressful in space, which is why they need to have stress level monitors. You see, too little stress and the work loses quality and efficiency. Basically, it's like an astronaut falling asleep on the moon. On the other hand, though, too much stress and the work can suffer from anxiety, fatigue, depression, and even heart disease. For astronauts, this balance is crucial to thriving in the high-risk environment of space. So, we need to monitor stress, but how? Currently, heart rate monitors are used to monitor the stress levels of astronauts. However, they don't really provide the user with as accurate readings as measuring cortisol would. You see, cortisol is a hormone in our bodies that tells us how stressed we are. One way it's released is through sweat, which is how our sensor works. So, cortisol sensor what? There are two parts to the sensor. One consists of an organic electrochemical transistor, or also known as an OECT, and also molecular imprinted polymer, or MIP for short. The organic electrochemical transistor, or OECT, is basically just a biosensor that uses the injection of ions from an electrolyte to control current between a drain and source electrode. Just like you can't have peanut butter without jelly, you also can't have an OECT without an MIP. By itself, cortisol cannot be detected by the OECT because it's a nonpolar substance. The MIP is positioned between the sweat sample and the OECT. As the sweat solution diffuses across the MIP and into the OECT's channel, cortisol binds to the monomers in the polymer, blocking and building resistance that prevents ions from flowing through the channel. A microcontroller can then be used to assess the differences in voltage and current caused by the collection of cortisol, which is then used to assess the wearer's stress. This circuit diagram depicts how the OECT will be integrated into a larger circuit. Every device needs a structure. When deciding where the wearable would be on the body, we needed a location that was comfortable, as if the astronaut was relaxing on a beach. We needed a place that was easily allowed for the collection of sweat and was functional to attach electronics. The structure is a water-resistant waistband that connects to the lower back of the user. It's comfortable for someone to wear the whole day and in a place that gathers sweat easily. The pouch holds the microcontroller battery and wires that connect to the OECT, which is underneath the waistband. This sensor is a tool that allows researchers to better understand how humans adapt to extreme environments like space, and how they can thrive when faced with new and exciting challenges like visiting Mars. Thank you!